are talking about memory management and ARC, or automatic reference counting in Swift, right? So Swift uses ARC to track and manage your app's memory usage. Before ARC got introduced to Swift Objective-C, developers had to manage their own memory. So I create an object, I would have to understand how to manage the memory, meaning if I create object A, I would have to say, okay, now my retain cycle is 1. So every time I create an object, I would have to manually have the retain cycles and the release cycles in my code. So I know I create one object, I have one retain cycle. I create 2 objects, I have 2 retain cycles, and I would have to know, hey, I'm not using that object anymore, I have to release it manually. So I would have to say object A, release, object B, release. That was before ARC got introduced in iOS. We had to manage our own memory as developers. Now, ARC got introduced, maybe 5, 6, even longer than that. ARC got introduced really early in iOS development. So ARC is a way for the system to manage the memory for us. No longer as developers, we're the one counting how many retain cycles we have and how many releases we have to do, right? So ARC took a lot of the heavy lifting out of development for us and help us focus more on developing our app and make our app stand out to our audience. But ARC has its limitations, right? Not every memory is managed by ARC. There's certain points in our code we have to manage the memory ourselves. A typical example, in our closures, for example, we've been, for the last 2 weeks or 3 weeks, we've been saying, hey, if we're in a closure and we have self getting captured in a closure, that could be a memory leak, that could be a strong reference cycle or a retain cycle. What is a retain cycle or a strong reference cycle? Basically, you have a had and you have Julia holding on to the same object. They're holding on to that same object. Both of them have a strong reference to that object. So there's no way, even if a had goes away and Julia goes away, they still have a strong reference to that object. That object doesn't get released, right? That memory doesn't get released. So what happens is a memory leak. So you have your closure, it captures self, right? Self, a closure is a reference type in Swift, right? A closure is seen the same as a class. A struct is not a reference type. So we do not worry about structs when it comes to memory management, but we worry about classes. If you have a class, if you have a closure, all those are reference types. So those you have to be very careful with. You have your closure, the minute you say self something, you have to stop. We'll come into it later with code, but now I'm talking about the theory behind it. So ARC is the memory management tool in iOS development. ARC. What does ARC do? ARC manages our memory. Most of our memory, 90% of the memory is managed by this management system. But when it comes to recreating our own closures or our own types, our classes, we have to be careful. If you have 2 objects holding a strong reference, 2 classes holding a strong reference to an object, that creates what is known as a strong reference cycle. And that's bad. Because what happens, both objects have a strong reference to it. One object leaves memory, that object still has a hold to that particular object. And that creates a retain cycle, that creates a memory leak. So the big objective of today is to recognize memory leaks and fix them. A memory leak will eventually lead to a crash in your application, right? The more memory leaks you have, the more resources your app grabs. At some point, the operating system will kill your app because it runs out of memory. At what particular point it runs out of memory, there's no exact number on that, but the app will crash if you have memory leaks there. So you have to be very careful. And today we'll see how to actually see memory leaks in our application, how to fix it. Okay. So we said what ARC is. ARC is a management system that basically keeps count of how many objects you have in memory, and when those objects get set to nil, or when those objects are to be destroyed, ARC gets rid of that particular memory in the app for you. So app handles that for us, okay? Okay, let's go to the example that Apple uses to talk about it. Okay, so here we have a person class. We have a person class. It has a name string. Can everybody see in the back? Should I blow that up? Can we all see now? Okay, so here I have a class called person. Person has a property called name. It has an initializer. Great. And we've never seen this before, but we have a dinit. That dinit here is called a deinitializer. The same way we have an initializer gets called when an object gets created. When the object gets destroyed, the deinitializer gets called on that object. Right? So if the object gets created, print whatever the person name is being initialized, gets printed. If I set this person to nil, the deinitializer should get called. If that doesn't get called, very quickly we'll notice that this particular object is being licked, right? This particular object is not being released by arc. If your deinitializer is not getting called and you set your object to nil, this is an indication that your person object is being licked. Somebody else has a strong reference to it. As long as somebody has a strong reference to person, that object will never get deallocated, or that object will never get deinitialized. That here is the basis of memory leaks in your application. If the deinitializer is not getting called, you have a memory leak. The more memory leaks you have, the more resources your app will grab. Eventually, it will crash. Apple shows us here in that particular example, if we have 3 references, person, reference 1 gets initialized with a person named John. So reference 1 currently has a pointer to this object, person. We go down, reference 2 and reference 3, both now are pointing to the same object. Any questions about that? We have 3 references, they're all pointing to the same person, right? This is classes, this is reference types. Again, when we talk about reference types and memory leaks, they only pertain to classes, closures. Anything that has a reference associated to it. Doesn't pertain to enums, does not pertain to structs, right? Everybody? Right? So structs are value types. There's no reference counting. There's only reference counting on classes, closures. Anything that has reference types associated to it. Okay? I want to make sure that we all understand that and we all explain that to the interviewer. Right? With structs, we do not keep references. There's no references on the struct, period. Right? There's no reference counting on structs, enums. Those are value types. They're passed by value. This copy is being passed around, not references. Yeah, classes, yes, exactly. You have to be careful with classes, especially when you say var some object. We'll talk about what that looks like. But yes, classes, that's the big one. That causes the memory issues. Great. So here we have reference 1 being set to nil. So at this point, reference 1 is nil. Reference 2 is nil. Does my object get deallocated? That's the big question here, right? Does my object get deallocated? Reference 1 is nil. Reference 2 is nil. What about reference 3? Is reference 3 still nil? It's not nil, correct? So there's still a strong reference to this person object. This person object is still in memory. This here is the fundamental concept of understanding what's happening. Let's go back again through it. We have 3 references. They're all nil. They're all defaulted to nil because they're all optionals. We have reference 1, it's an optional, it's nil. Reference 2, optional, nil. Reference 3, optional, nil. We go on, we say, hey, reference 3 gets assigned a reference to this person object. We created this person object, that person is called John Appleseed, right? Currently, reference 1 is pointing to John Appleseed. Any questions about that, right? So we go on, we say, okay, reference 2, you now also have a pointer to what reference 1 is pointing to. What is reference 1 pointing to? To person, right? To John Appleseed, correct? So if I assign reference 2, remember back in unit 1 when we said what happens if I change reference 2? It also affects reference 1's object, correct? Because they're now all pointing to the same object. Here is that fundamental there that we have to bring back from unit 1 to unit 3 to talk about memory management, right? Because now all three references are pointing to the same person. They're all pointing to the same person. Even if reference 1 and reference 2 set themselves to nil, that person is not getting deallocated. That deinitializer will never get called because I still have a strong reference somewhere. In my code, I still have a strong reference. Somebody still says, I need to still use this person. So I still have a reference to that person. Right? So the deinitializer here, this deinitializer will never get called because reference 3 still has a hold on it. The only way it gets called if reference 3 says, hey, I no longer need that object. Then the deinitializer will get called. Okay.
So we have to put that deinitializer in the class.
In the
That we have to, at some point, we have to get rid of.
Exactly. This is one mechanism. So Luba is bringing up a point. Do we have to put the deinitializer to know our objects get deallocated? For that particular example, yes. But there's a next tool we'll see later in Xcode that shows us if we have memory leaks in our application. So the project I sent out, we have some memory leaks there. One way is to see if the initializer gets called and to investigate what has a stronghold on it. A next way is to use what's known as the memory graph debugger. There's a memory graph debugger new to Xcode, maybe 4 versions or 3 versions of Xcode has it in there. When you turn that on, you'll see if you have memory leaks in your application. You'll be able to click on it. You'll be able to see visually what object has a stronghold on the next object, right? But the deinitializer is a quick way to also see that, right? Great. So let's go on here. So we have the 2 references. We understand that. The only time here that they show us, if reference 3 is nil, then the deinitializer gets called. Do we all see that? Right? So when reference 3 says, hey, I no longer have a hold on you, then that object has no more strong references to it. Then the deinitializer will get called at this point, right? Because it had 3 references to it, it wouldn't get called if 2 references got set to nil. But as all 3 references got set to nil, now the object says, okay, Arc says, nobody's holding on to you, I will free you out of memory. I'm going to release you. That's what Arc does, right? But Arc doesn't have enough information to know that, hey, at this point here, Arc cannot just come around and just free up your object. That would be bad, right? Because here you're still saying, as the developer, I still have a reference to person. I don't want to let go of person. So there's no way for Arc to come in. Arc is very powerful, but there's no way for Arc to come in and say, hey, I'm going to free this object right now. That would be horrible, right? It's up to us, the developer, at this point to say, hey, we have no more references to it. Make sure all our objects are set into nil. That way, Arc does its job, right? Arc only does its job when there's no more strong references to that object. If we have to write one piece of information down, that's what we need to write down, right? So Arc will only free memory when there's no more strong references to that particular object, period. Again, Arc will only free memory on an object when there's no longer strong references to that object. Very similar to what we have here. We have 3 references pointing to an object. 2 of those references got set to nil. Will Arc still release the object? No, right? Why? Because the third one still has a strong reference to it. And at this point here, the third one does release that object because it's set to nil. Yulia, questions? Cool. Any questions? Yes?
What is it though when reference 1 is set to nil?
Reference 1 is set to nil. Here?
Yeah, that the initializer gets called.
Oh, it doesn't.
No, it doesn't get called. Why is that?
Because there's still 2 references to it. There's still two strong references to it. This object has still 2 references to it.
But not when the object becomes nil overall.
Oh, no, right? That's what Arc says. Arc says the only way I'll release an object from memory when there's no longer any references to that object. Okay? Let me see if I could bring up a drawing for us here to better describe it.
Or any strong references or references?
Any strong references. It has to be a strong reference. It has to be a strong reference. That's why we'll talk about weak references and unowned references in a little bit today. But for now, it's a strong reference. We're only talking about strong references. All right, so. Okay. We have a person object, right? Very similar to what we have in our diagram here. So reference 2, reference 3, and reference 1 are all pointing to person. Do we agree? Tiffany? Do we agree, right? So we have reference 1, 2, and 3 pointing to object person. Do we see that? So we have 3 strong references pointing to the object person. Okay, great. So when reference 1 and reference 2 sets themselves to nil, let's go ahead and take that out. So reference 1 is no longer pointing to it. Do we see that, right? It's nil. Reference 2 is no longer pointing to the object. But reference 3 is still pointing to it. So that's why the deinitializer will never get called. Bienvenido? Right? See that? Questions? Question?
As long as there's still a strong reference on the object, it will not get
They did exactly. It will not get released from memory.
regardless of the fact that the person object is set to nil.
The person object has not been set to nil. The reference to that object, right? Right here, the reference here, the reference got set to nil, not the person object, the reference. Right? The reference is that constant or that variable that you declare, right? The variable there, that's what's pointing to the person object. So even if we said reference is set to nil here, and reference 2 is set to nil, right? We had those, and we said no longer are they pointing to it, but there's still reference 3 pointing to it. So it's still in memory. Benvenido? Right, questions? Yes, sir, Mr. Wan.
I thought the way it would look is that reference 1 points to person. So you could buy it as
Reference 1 points to person. Oops, sorry. Reference 1 points to person, reference 2 points to person, right?
I thought reference 2 will point to reference 1 that points to person.
They're pointing to the same object. Remember back in Unit 1 when we spoke about classes pointing to the same object? This here is the object. We only have one person so far. Only one person exists. That person name is John Appleseed. Right? Going back to our person here. There's only one object in this whole particular example here. That one object is the person where the name is John Appleseed. Do you see that?
When you say reference 2 equals reference 1, it just points to
The same person. Everybody sees that? Right, so I'm passing a piece of paper. I have one object, paper. I'm passing it throughout the class. I have one object, paper. Everybody's writing their names on it. It's one object. Everybody has their name on that object. Any questions about that? Because that there is fundamental, right? So if we have to take one thing home, that's the thing we have to take home. Creating multiple references pointing to the same object, that's what we illustrate in here with that example. Ref 1, 2, 3 pointing to the same person. This person here is John Appleseed. Right? It's not 3 individual objects. That would be different. If we had 3 different objects, every reference pointing to their own object, there would be different objects. Everybody with me? But we created one object. It got passed to reference 1. Reference 2 got created. Reference 2 also is equal to reference 1. Reference 2 is also equal to reference 1. So they all end up pointing to the same object. Right? And that object is person. Person has the name John Appleseed. So when we talk about memory management, if you have multiple references, strong references pointing to the same object, that object only gets released when all the strong references are set to nil. So the only way my person object gets released is if this is gone, and this is gone. At this point, person gets freed from memory. Any questions?
To clarify, setting it to null is the way to remove the strong.
Yes.
So what, how do you do it?
How would I do?
Actually, no, I'll probably do
No, that's fine because reference 1 here is nil, correct?
Yeah.
Reference 2 is nil, correct? So if we have to go back here, so reference 1, let's go back again. Again, this is important, so we want to stay here. Reference 1 is nil, right? If I say reference 1 is nil, it's not pointing to my person object anymore, correct? You agree? If I say reference 2 is nil, my arrow goes away. Is person going away? No, because there's still a strong reference to it. And the way we get rid of that is we set it to nil. At some point here, I could put a reference here. If I say reference 3 equal to nil, at that point, after the phone call, right? If I say reference 3 equal to nil, my arrow goes away, and at that point, the object will get freed from memory, okay? And that pertains to strong references. Yes? Arc, what is Arc itself? Arc is the mechanism that Apple uses or iOS uses to manage memory. So it will take care of memory for us. If everything is nil, it will free it. The operating system at this point will free it from existence. We don't need it. We just put it there for illustration purposes to see if it gets called. But you don't need to put it in there explicitly for Arc to take care of what it needs to take care of. It lets you know that, hey, it wasn't called because something is still holding a reference to it, right? But Arc itself is the one that frees the memory. Like we're not saying anywhere in our code, free memory, right? Arc is the one doing that. Okay, cool. Any questions before we move on? Okay, so Swift reference types, we spoke about that. Let's talk about strong reference, weak reference, and unowned reference. So by default, let me blow that up a little bit. By default, if you declare, in our case there, the reference, if reference is declared with a var, if it's declared with a var, by default, it's a strong reference. Everybody? So here, if I say var, favorite person, that is a strong reference. I do not explicitly say strong in front of var, right? Same way we have a public, where we say public var, by default it's public. Here, by default, if you simply say var, favorite person, it is a strong reference, okay? And we're referring to a class here. It has to be a class here. If it's a struct, it's not reference counting. You don't have to worry about it. But if it's a class where person is a class, then that creates a strong reference to person, favorite person. Moving on, we've seen weak var before. Where have we seen weak var? The what? Right, we've seen them in outlets, right? All over iOS development, especially, right? We've seen IB outlet weak var, right? So that here is a weak reference. The view controller doesn't have a strong reference to it, right? The view controller doesn't have a strong reference to it. It does not create a memory leak. Do we see that? Right? So when the particular outlet is no longer needed, there's no reference being leaked in memory. Right? So that's why we use weak here. It creates a weak reference. Weak reference does not create memory leaks, period. Right? You get memory leaks when you have a strong reference to objects. So both of them have a strong hold to each other. They'll forever have a strong hold to each other, to that object, unless both of them get set to nil. But once setting one to nil doesn't get rid of the object, as we saw with our reference on person. You have to explicitly set them nil everywhere that strong reference is. Okay. Unowned, we'll come more talk about unowned when we see closures, but for now, unowned, you use unowned if the object, right? You use unowned if the object that you have a reference to will have a shorter lifespan than you. If you have a shorter lifespan than you use unowned. A very typical example, Apple uses this example in our ACK reference we just saw. If a customer has a credit card, the credit card has a shorter lifespan than the customer. So the customer will have a weak reference to that credit card, right? So the credit card doesn't have a strong reference to the customer. It should not have. If you have a strong reference both sides, you create a memory leak. Do we see that? But the credit card itself has a shorter lifespan than the person, the customer. So the credit card would have a weak reference. So the minute that credit card is no longer needed, there's no reference count in there, there's no memory leak. So part of it is like really architecturing what your reference types looks like. So when you have multiple objects, if you have, for example, a credit card, you won't have like var person on the credit card and var credit card on the person. That would create a strong reference cycle. We'll see it in the project I sent out because we have memory leaks right there. And the deinitializer doesn't get called because there's strong references. But remember, var is strong reference by default. A weak var, you use weak var if, for example, you don't know at what point that object will be nil. If there's any doubt with when that object will be nil, you want to use a weak var. Unowned, if you are guaranteed the object will have the same lifespan as you, if you guarantee that the object will have the same lifespan as you use unowned. But keep in mind that if you use unowned and you try to access an object that's no longer in memory, your app will crash. So if the credit card, I would use a weak var on that credit card. But if you use unowned on that credit card and the credit card is nil, and you try to access that credit card, your app will crash. Yes?
So are you supposed to variables like for the benefit of the developer, or just like use something?
Say that again.
Like you see, you said like you use it if you bar unowned bar if you know that the
Well, that's for memory management, right? Not for the next developer to read. It's for memory management.
so it actually like does something for the memory, like it's gonna like help.
Like if all your objects are var, if all your objects are strong references, they all will have holes onto each other. And that will create a memory leak, right? That's what we're talking about. So if you have the reference, for example, your 3 references to person, they all have a strong reference to person. They all need to be nailed out in order for that object to get released. So it's up to you, the developer, to think of how you architecture your objects so that you don't create memory leaks in your code. They will happen eventually, right? You will create memory leaks. So that's why Xcode gives us tools to see where those memory leaks happen. And that way we could debug our memory leaks. Because it's something that happens. Like you code, you're not realizing you have a var somewhere, a strong reference to a next object, right? You're going along, you're coding, then you realize your app is running slow or your app crashes for some reason, right? Because of some memory issue. So you'll be able to see what the memory graph looks like later, and you'll be able to recognize where you have memory issues. Xcode is doing a really good job every year with trying to do memory management as tools that we use in Xcode to see our issues. Cool. Yes, question. The object you have a hold on has a shorter lifespan than you. You'll see what that looks like in code. It's hard for me to talk about it. But basically, unknown reference, object A has a hold on to object B. It uses unowned if object A has a shorter lifespan than object B, right? I'll show you what that looks like. I know it's hard to explain it just talking about it. But actually, let me phrase it again in a different way. So unowned, you'll use if both objects have the same lifespan. Yes. Very loosely, you have to be sure that you know exactly both objects have the same lifespan as each other. Other than that, use weak. If you're in doubt, you use weak var. They both will be deallocated at the same time, destroyed at the same time, set to nil at the same time. They both will go out of view at the same time. For example, you have a UI view controller. You have an alert controller. Even the alert controller will actually go out of memory before, which is fine. You could use unowned there because the view controller has a hold on the alert controller. The view controller will still be around when the alert controller gets released, right? So that's unowned. But you have a closure. You don't know at what point that closure will be nil or the view controller will be nil. So you want to use weak. Okay? It depends on the lifespan of the object. And if you're in doubt, you always want to use a weak reference. Okay? The example of the customer is a weak reference because the credit card will have a shorter lifespan than the customer. Because the customer could have many credit cards. So again, you use unowned when two objects have the same lifespan as each other. You use weak when one of the objects will be out of memory or deallocated before that other object is. And when you use a strong reference, be very careful that your object itself doesn't have a strong reference to multiple other objects. So here we say strong references are the default, right? Weak references are a way of making a reference to an object without it counting towards arc. So arc does not keep count of weak references. Arc only keeps count of strong references. So you have two objects, they're pointing strongly at each other. Arc will say there's two reference counts there because both objects point into each other. So each has one reference count. So that'll be two reference counts. And to highlight here, be very careful with unowned, because if one of the objects that you think still exists, you try to access it, it will crash your app. So use unowned only if you know both objects will be in memory for the same duration of time.
So it's unknown, like what's the matching?
Yes, because unknown doesn't use optionals, so that's a very good point, Howard. Because when we see in our closure example, if we say unowned on a UI alert controller, for example, there's no self question mark there because it's force unwrapping. Like you're saying, you guarantee the object will exist. And if you fail, your app will crash. But with the weak, you're saying, oh, there's a possibility that object I'm trying to point to doesn't exist. So it's optional, and your app won't crash. Okay? But at the same time, again, the more experience you have using weak and unknown, the more you'll know when to use them, because there's points where you're better off using unowned if you want to access that object without an optional. Right? You'll come to those later where you say like, oh, I need that object, but it's an optional. It should not be an optional. It needs to be exist. So it has to be unowned. Right? So there's a line there, but that line we'll get to it with more experience as we get there. That's why there's so many articles being written about weak and unknown, because it's one of those topics. It could be abstract. It's not super abstract, but at the same time, the more you use it, the more you'll understand why you use unowned versus weak and what unowned gives you. Like with what Howard is saying, unowned is very similar to force unwrapping. I guarantee that the recipe cell is a recipe cell. I force unwrap it, right? It's never going to crash because I guarantee there's a recipe cell. But the one instance where it's not a recipe cell, or for some reason, right, you expect a name, the user doesn't give you a name, or you expect an int, the user gives you a string, and you force unwrap that int optional there, that'd be dangerous. Yes?
We use weak references when we're doing it, when we've done outlets in the past.
Where else have you seen it? Where else have we seen weak? Outlet, what else? We created something in Unit 2. It was a delegate. And we said that delegate should have a weak reference to the object that's being the delegate, right? So on a delegate, we created a protocol before. We created like the heart rate protocol earlier, right? Some lab. Who remembers that lab? Tiffany, you did that lab, right?
I'm sure I did.
Okay. Ahad, you did that lab,
Which one?
the heart rate lab, delegation,
Yeah.
right? And we said weak delegate.
Yeah, we did.
Yes. And all your delegates on your table views, by the way, they're weak delegates, right? Because the view controller cannot have a strong pointer back to the delegate, right? Because that would create a reference cycle. So whenever we're creating our own protocols and delegation, we have to say weak delegate on that variable. If we say var, it will have a strong reference. They'll never get released out of memory. They both will be pointing to each other. So be very careful there. That's the next place we see it. When we create a delegate, we have to set that property to weak. For retain cycles, we see that in our lab, not the lab, but the actual project we sent out, we have this example. So we'll see what that looks in code. Better seen in code here. Again, better seen in code. We have the code. And we'll see what that looks like again in Xcode. We have this memory graph. Where we click it, we actually see in memory a retain cycle. We'll actually see the apartment and the tenant both have a strong pointer to each other. So we'll actually see that in code. Everybody has the code I sent out? Let's actually go to the code and talk about more memory issues here and how to resolve them. Okay. Let's open it up. Okay. Something I haven't exactly done with us yet is to separate our files into folders. We'll do more of that as we go into more bigger projects. We might do that in the post project because that'd be a bigger project. But here I separated our projects or our files in folders, right? So we have our models. Here we have 3 models. We have a person, an apartment, and a lab. Everybody has access to that project, right? I don't want to keep going on unless we all have it. Margia, do you have it? Okay. So we have 3 models, we have 2 controllers, and we put like supporting files in a supporting files folder. But the projects or the files we're interested in today, let's go to the first view controller. Let's go to view controller. So view controller has view did load simply prints out view did load. It calls configure person apartment. Configure person apartment creates 2 variables. It has a person and it has an apartment. The person has a name, the apartment has a unit number, right? And now the person has a pointer to an apartment, right? The person now has an apartment, and the apartment has a tenant. So now we say, go ahead, and the person no longer exists, and the apartment no longer exists. So if we run the app, the deinitializers for both of those should get called, correct? Because we set both objects to nil. The deinitializer should be called on both objects. If we go back to our person object has a deinitializer, right? Everybody sees that? Does everybody see their person object? Tiffany? And the apartment also has a deinitializer. And we said that the deinitializer is a method that Apple gives us to see when our objects get deallocated or destroyed. Right, everybody? When my object gets destroyed, this gets called. Let's see in an example here. Let's just create an object. Go back to your view controller. And let's create an object. Let's create a fellow. Fellow has a name. Fellow has a cohort. Right? fellow has an initializer, fellow has a deinitializer. Again, deinitializers are only available in classes, right? Only available in classes, not structs. Again, only reference types gets destroyed. So here we have our initializer. It takes in a name, a string, and it takes in a cohort. And here we set up our fellow name is name, and our fellow cohort is cohort. Okay, great. And at this point, we'll simply put out a print statement and say fellow with name was created. Okay, so that's it. The initializer gets called when the object gets created. Cohort. I'm missing double here. Yes, sir.
That was it.
Okay, cool. Thank you. So initializers called upon object creation. And deinitializers only available to classes. Yeah, and closures, but closures, there's no innate on a closure. But a closure is just a reference type as far as like keeping track of the references on the heap or in memory, sorry. And here we have only available to classes called when object is the initialized or deallocated or destroyed. All those are valid names. And I could also say or set to nil. So here we'll simply have a print statement and say name was deinitialized. Cool? So know what an initializer does and know what a deinitializer does as far as classes are concerned, right? Let's go ahead in our view did load. Let's simply create a fellow. So before doing anything, let's just run our app and let's see what happens. Well, not on the iPad, sir. I created on the iPad. Stop this. Var, let's do let fellow 1 equal to fellow. And run it on your simulator. Let me do that. This is not gonna. Just do one. Let's do one refactoring. Sorry. The fellow needs to exist in the class because that goes out of scope. Let's go to viewDidLoad right here and say var fellow. Var fellow is fellow, optional like that. And then here we have our fellow. This is great. And then here we'll have var fellow. One is fellow. Anybody realize what happened here? So it got deinitialized because viewDidLoad got out of scope. My object is local. That also got out of scope. But what we want to illustrate here is the fellow exists in the class, and that fellow doesn't get deinitialized unless we say fellow nil. So that's why I had to go ahead and do fellow var outside of my viewDidLoad. Because remember, scope, it goes out of scope, the object gets destroyed.
So what's the keyword?
Yeah, that makes sense, right? Because it's local to viewDidLoad. So now let's run the app again. But if you test it in Playgrounds, Playgrounds is around, right? It's like one of those things. Exactly. All right. Everybody, did you refactor your code? You have two fellows outside of your viewDidLoad, right? They're optionals. In the viewDidLoad, we have fellow. And we have fellow random fellow in cohort was created. We do not have the deinitializer. The deinitializer does not get called because that fellow hasn't been destroyed yet. Right? Was everybody able to see that? Let's go back through it again. So here we have a fellow. We create a fellow from this random fellow. And fellow one also points to fellow, first fellow. Our initializer gets called on the fellow. The initializer here gets called. But the deinitializer does not get called because that object hasn't been destroyed. The object we had before, if it was local in the viewDidLoad, which we had before, it would get destroyed because the minute viewDidLoad gets set up, that gets freed because it's a local variable, our deinitializer gets called. That's not what we want to illustrate. We want to illustrate if I create my fellow object, it's in memory, and it remains in memory unless I explicitly say object equal to nil. Okay? All of us should now have only fellow random fellow in 4.0 cohort was created. The deinitializer does not get called. So let's go ahead and try to make the deinitializer get called. So we'll say fellow equal to nil. Will that be enough to get my deinitializer to get called? All right, very good. Let's test it out. Right? Object is still alive. The object is still alive. Random fellow lives on. Right? Let's also set fellow one to nil. And run the app again. At this point, the random fellow was deinitialized. Do we see that? Right? So at that point, there's no more memory fellow existing. Arc has taken care of it. Arc went ahead. We do not call, by the way, let me point it out. We do not call deinitializer explicitly. We do not call the deinit explicitly. The same way we don't call init, where we create an object, but we don't explicitly call it. Everybody with me? I don't explicitly call deinit on my object. Arc is the one that manages the deinit for us. We specifically wrote it. That way we could see or have some print statement in there. When the object gets deinitialized, it prints out, hey, object got deinitialized. Okay? So we were successfully able to release the fellow from memory. Questions? Yes? We don't use Arc. Arc is built into the operating system.
I mean, so like, say you have an app, are you waiting for it to say like, hey, I have this?
You should, well, most likely than not, developers actually do that. Like they wait when the app is slow to go debug it, right? That's unit tests and everything, right? We don't fix it unless it's broken. Same thing with memory management. We build our app, we don't take a look at the memory graph. we don't see if we allocate in memory. But the minute we get memory warnings, that's where we go in and we dive, which is bad, right? So as a good developer, you want to really address earlier than later. Is my object then created correctly? Do I need a strong reference to object B? Like, do I need to say var some object, or can I say weak on that object? Like answering those questions earlier is the way you want to go. But again, 80% of the time, it will happen when the app crashes. Then you go back, right? We all like retrospect. We go back and we're like, oh, there's a memory issue maybe because it's always crashing when I create 5 customers or whatever it is, right? Then you're saying, oh, there's 5 customers creating a memory leak because they have a next object holding on to. Cool. Does that answer your question? Right. All right. So this is our fellow example. Let's take the fellow code out. The fellow example was just for showing us how the initializer gets called. We know that now. We could keep the fellow here for your own purposes. This example project, by the way, you come back to it before you go to your interview and really understand all the fundamentals of talking about memory management, right? What is Arc, right? What does Arc do for us? What's the limitations of Arc? The limitations of Arc is what we see in today. There's issues where the system itself doesn't have enough information to say, I can't release that memory. With our 3 references, Arc did not have enough information to say, oh, there's still a reference to our person. I cannot just go ahead and release the memory. You, the developer, have to give Arc that intent. I need to release this memory, so I set everything to nil. Or I need to release that memory, I set one of the objects as a weak reference. So let's see what's happening with this particular application. So that particular application, if we run it again, view load, right? Our problem is our deinitializer is not getting called. In our configure person apartment, we're setting both objects to nil. So let's see what's happening there. Both objects are getting set to nil. Why aren't they deinitializers getting called? Does anybody see it yet? So if we see our person object, right? Person object, what set of pointer is this? What sort of reference is apartment on person? Is it weak? Is it unowned? Is it strong? What sort of reference is this? It's a strong reference, right? So the person has a strong reference to apartment. Do we see that? Right? Let's go back to apartment. Because it's a var, exactly. Let's go back to apartment. What sort of reference is this? Not this one, sorry. That's a struct here. What sort of reference is this? Yulia, what sort of reference is this? So do we agree that both the apartment and the person has a strong reference to each other? Right? So if we go back to our diagram here, we can make a diagram. We probably have one. Go back to person.
Yeah, you said in person has apartment, and then apartment has person.
Yes, and they're both of vars. They both have strong references. Because remember var here, var is strong reference by default. Right? So var is a strong reference by default. Great. Let us see what the memory graph gives us. So if we go to, let me zoom in here. Do we all see this memory graph at the bottom there? It says debug memory graph. Do we see the debug memory graph there? At the bottom of the debugger? Tanya? Good? You good? Okay. Do we all see the memory graph? To the left of the memory graph is a view hierarchy. The view hierarchy enables you to see your simulator, the view of your simulator. So go ahead and click on the memory on the view graph. I just want to take a look at this. There's no elements here, but just click on it. If you click on the view hierarchy, you're able to investigate your view by moving it around. Can we all do that? Did we all click on the view hierarchy, the view debugger? Bienvenido? Okay, let me go back to it. Stop us if you don't see it, sir. So let's zoom in here. I have the memory graph debugger, and I have the view hierarchy to the left of it. If there's some issue wrong with your constraint, for example, you could click on the view debugger, click on it, and able to investigate by turning it around in the 3D model and see, hey, maybe there's a view behind my label, right? Or I think Lilia is not here, but I was able to see Lilia's table view was showing her result, but the result was not constrained correctly. So the result was coming out of behind the bar somehow, right? So we were able to see it in the view debugger. So the view debugger is an awesome way to debug your views. I wanted to show it now because I haven't explicitly shown it to us, but the view debugger comes in very useful when you want to debug your views. Like, hey, I have a button. I know the button exists. Jump in the view debugger, see if the button is behind somewhere, or if it's maybe in 0, 0 because the frame is not correct, whatever it is. Okay? So I showed us what the view debugger is. We'll keep seeing it more and more as we develop our UI. But today, what are we interested in? So continue executing your app by pressing on the play button. But what we're interested in today is the memory graph debugger. So click on the memory graph debugger. The 3 circles here resembles a graph. Click on it. It's building the memory graph. Building, building, building. Okay, you don't have to build that long now. Did you guys finish yet? Okay. Then yeah, I need more cores. All right, it's finally finished. Okay, let's see up here. Go to the very top. We haven't seen that sort of error before. We've seen yellow errors. We've seen red, well, we've seen yellow warnings. We've seen red errors. Today we've seen purple memory leaks. So if you see the number 3 here with the purple icon, do we see that at the very top of Xcode? If we click on it, we have memory issues, right? If you click on it, you'll see you have memory leaks. We got 3 leak types. If you click on the one that says one instance of apartment, click on it, open everything up, click on the apartment leaked. Here, we have 2 leaked memories because apartment has a strong hold on person, person has a strong hold on apartment. So here we have 2 leaked memory points in our application, right? And if we click on the number 2, you actually see it. There's 2 arrows. 1 arrow going from apartment to person, that's a tenant. 1 going from person to apartment. So we have a problem there. It tells us what the problem is. So our next step is to go break that. One way we could break it is making one of those objects a weak reference. Because right now, both objects are strong references, as we saw, right? A person has a strong reference to apartment with the var keyword. An apartment has a strong reference to a person with the strong keyword, with the var keyword. We saw that, correct? So now, go ahead, sorry.
I wanted to just double check, even though this set of apartment person to you, it still has a reference?
It's still, because remember, one is still have a reference to the other, right? Right, very similar to what we had earlier, because there's still a strong reference there. If both have a strong reference, setting one to nil doesn't, go ahead.
No, but the first time we had options, which we actually, we still have objects here, we kind of have almost like 2 objects, which accept.
This is what we have. So we have Alex, right? And we have apartment, whatever, 6B, right? Alex has a pointer to apartment, strong pointer, and apartment also has a strong pointer back to Alex, right? So even if we set Alex to nil, right? Even if I set Alex to nil, for example, I set Alex to nil, that takes care of this guy, right? But this guy still has a pointer, sorry. This still has a pointer to this, right? So it's like it's never gone away, right? And even if I set apartment to nil, right? It still has a pointer to this guy, right? So the objects still exist because both of them are strongholds on each other. The only way to break that cycle is to make one of them a weak reference. The only way is to make one of them a weak reference. Because what happens here is a cycle. You have a memory, a retain cycle. right? Where there's never, one object is never completely nil because both are pointing back to the object, right? It's like I'm holding on to you, you holding on to me, right? We both hold on to each other. Even if you get deallocated, or sorry, even if you set your object to nil, I'm still holding on to you. So you're still in memory.
So what will happen when we deallocate one on the
If one is weak at that point, then the object, once it sets to nil, it will get deallocated, right? Any questions about what Yule is asking for? Okay, so let's go back here and see what we could do. So we agreed that we could go back to the person. We could say a person doesn't always have an apartment. That's valid. So if I say a person doesn't always have an apartment, I would set that to weak. So that person doesn't always have an apartment. So I could simply say weak here. I could do weak on any object. I could do weak on the apartment. I could say apartment, weak tenant, or I could do person. It's up to me based on my architecture, what I want to do. So in that particular example, I want to say the person has a weak pointer to the apartment. I'll build my application. I'll run my application. So run your application and go back to the memory debugger and see if you still have memory issues. Actually, we don't have memory issues. What happened in our console? What's different in our console as we did weak var? The deinitializers got called on both objects, right? Do we see that? So we could confirm, we could go back to the debugger, to the memory debugger, click on the memory debugger. There's no issues, there's no purple errors here. There's no purple issues there. Do we see that? Right, everything is gone, right? Our object got deallocated, Xcode is happy, our app is happy. So as developers, when we start creating classes like this, and you have a strong reference to a next class, stop and say, hey, do I need a strong reference here, or should that be weak? Okay? That's why we need to start implementing it.
so it can be weak, it can be strong if the other class doesn't have reference.
If the other class itself has a weak reference to it. This one is weak here, right? But the other class is strong, that's fine. Okay?
If apartment didn't have reference to the person,
Yeah, that's fine. Like if apartment didn't have a person, we would have no issue, right? But because it's pointing to person, yeah, you have a strong reference on both sides. One of them needs to be weak. Okay? Any questions about class to class strong reference cycles? We spoke about arc, we spoke about strong references, also known as retained cycles. We explained strong, weak, and unowned. We've just seen one example of two classes having strong references to each other, and we're able to fix it, right? I will actually post that up, so when you're reviewing for your interview, please come back to this arc and really go back and know what's going on, because it's very important. And as you're submitting your apps yourself, run the memory debugger and see if you have memory issues. Yes, sir.
So like, will we have to, like when we start using our helper classes, like the network helper and stuff,
Yeah.
are there times where we should be using the memory debugger as well for that kind of thing?
As long as it's your code, it should be memory leak free, if that makes sense.
Okay.
Right? There might be issues where iOS itself will show you a memory leak with its own framework. It will take care of it itself. You don't worry about it. But anything you're writing yourself, you need to worry about.
Okay.
Right? And if you see something in there, will help let us know, like, hey, dude, like something is, right? Any other questions? Yes,
So
sir.
you accidentally made both variables weak, then making one of them no will be much nicer.
Yeah, but you don't want to start making everything weak, right? You have to, like if you need a strong reference to it because you need that object, which makes sense to your application. Yeah, does that make sense? Like don't go put in weak everywhere, right? Because the view controller needs a certain object for the life of it. Then it needs a strong pointer to it. It goes back to if that object, if I'm the one only having a hold on that object, and I'll be the one setting that object to nil, I want to have a strong reference to that object. Okay, so keep going here. that takes us into the last topic of the day, which is closures and capture list. We've used them before, but we'll reintroduce them again and talk about them. And know that closures are reference types, right? They're not value types. Closures are reference types. So with that said, let's go back to our view controller. And we have a configure lab controller here. Uncomment it out, and let's run it. Configure lab controller, what does it do? I'll talk about it right now. So uncomment configure lab controller, uncomment it, and let's see what configure lab controller does. It creates a lab. It creates a lab controller, right? And it marks a lab as being complete by calling the mark complete function, and it passes a lab. Let's see what the mark complete function does. Go to your lab view controller. Go to your lab view controller. So we have labs here. We have an array of labs. We create 25 labs by using the array repeat in here. Recursion, 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 get it? So we have 25 labs. We have a lazy var, which is a closure. It captures our closure. Remember, closures captures their surroundings. So we have a closure here. It captures self. Keep in mind that, let's put a note here. Using self or requiring self in, is it 26? Oh, sorry, if you have 26, that's fine. The one I zipped probably has 26. It's fine. So requiring self enclosures is a way for Swift to remind us that capturing self is a strong reference and can lead to memory leaks. All right. So what that says is like, hey, you have a closure. The minute you have to start doing self explicitly, so there's two places where we do self explicitly. One is in the initializer, and the next place is a closure. So anytime you catch yourself writing self in a closure, stop and say, hey, should this be a capture list? Should it be weak self, or should it be unowned self? Right? So here, should we use the capture list? Capture list is that syntax here, where you say is weak self. This is called capture list. This is the way Swift provides us a way to break the memory cycle or the retain cycle with this capture list. So should we use a capture list weak self or unowned? Or unowned self. Okay? Again, weak self is used when the object reference could be nil before could be nil. That's it. That's fine. And we use unknown self when both objects will be deallocated at the same time. Okay? So that one there is very crucial. You could use it, but you have to make sure that when you're using it, both objects are in existence for the same period of time. Most times you'll use weak self, Because most times your closure, your view controller, whatever it is, your closure will go out of existence, or your view controller will be like, hey, I'm done, let me go to a next view. It might get destroyed before the closure comes back. If that happens and you use unowned, your app will crash. So default to use weak self, right? So here we have, actually we did not run the debugger. So let's run the debugger before we fix it. So run the code, run the app, click on your memory debugger. Click on your memory debugger. Let's see if we have any issues here. How many issues do we have? How many memory leaks do we have? We saw 3, correct? So let me zoom in here. We have 3, we click on it. And here we have 3 issues, right? One instance of lab view controller. This is the big one we're after. So the lab view controller, here. The lab view controller has a hold on the closure. The closure itself has a hold on the lab controller. In the closure, let's go back to the closure. You guys could stay in your view, in your Xcode. I'll go back to the lab controller. Let's go back to the lab controller. The big piece of code we're looking at is that closure, right? We have our closure. It has an argument lab. It's capturing self. When I say capture, we have self.labs there. It's capturing self. It has a reference now. Remember, closures are reference types. Closures are a box. It captures the values inside of the body of the function, right? This is a function, right? It's a closure. It's a function, right? In the open curly and the closed curly, if we have self there, we capture in self. We're now saying we have a reference to self, right? And self now has a reference to the closure. So there's a strong reference there. There's a strong reference cycle that got created. And now we have a memory leak. We have a memory leak because both objects cannot now get deallocated. They cannot get deallocated because they both have a hold on each other. So we have to set one of them weak or unowned. The only way we break reference cycles is to set one of the objects either weak or unowned. Okay? Both of those objects cannot be strong references. Yes, go ahead. No, go ahead. Ask the question.
No, basically, we did make made a reference to self.
Yes.
I doing that in appending that to self, which is the 25 that we had.
That's fine, like that. That's fine. But the big part there is saying self in the closure. By saying self in the closure, you now have a reference, right? You now capturing self on that closure. That closure now has a strong reference to self, right? If we go back to the memory debugger, I wish I could have just kept that there. If I go back to the memory debugger here, if I go back to the memory debugger, you see that? Now the closure itself captured self, so it now has a pointer to the view controller itself, right? And the view controller itself has a reference to the closure, right? So the only way to break it is either unowned, again, everybody, the only way to break reference cycles is either you use unowned or weak. Very similar to what we did with the 2 classes earlier. So how we could do that with a closure is using a capture list. So let's go back to our lab controller. And we spoke about capture list. So the capture list, either we use weak with a capture list. So the capture list itself, that's what it's called. Open square bracket, close square bracket. It's a list. And then here we have unowned. Either one of those two. In that particular example, right, we'll say weak self. So the way we write it out is right after your first curly bracket, you'll start your capture list. So I'll say weak self, right? I'll say weak self, and now weak itself is optional. Weak is optional, so I need to update myself to be an optional, and I need to update this self to be optional. And I'll use nil coalescing here because this is also optional. You see where I'm going with that? So that's why If you use unowned, you're like, oh, I'll use unowned because I'm guaranteeing that disclosure is around, so I don't have to do optional anymore. What if it's not? It's going to crash your app. So let's run the app again and see what we have in the debugger, in the memory debugger. So at this point, we've broken the strong reference cycle by using this capture list. So run your memory debugger. And let's see if we still have the 3 issues. So at this point, we have no more issues, no memory leaks. So get in use, if you do anything, as you run your application, just run the memory debugger and see if you have memory issues. And only investigate memory issues where you yourself created the memory leak, meaning it came from our lab controller or it came from our person class, right? So at this point, we solved the memory leak by using weak self. And again, you use unowned if you guarantee that both objects will be around for the duration of their lifetime, okay? If we use unowned here, both will be around the same amount of time. Like my view controller has an alert controller. The view controller will be around longer in that case. So using unowned is fine, right? But if it's a closure, meaning the view controller will go out of scope before the closure returns, you want to use weak. Because if it comes back and you try to access it with unowned, it will crash your app. Because that object is no longer around. It's nil. So here, if I say unowned here, and I say self, unowned, then it's almost like force unwrapping, as Howard said. I don't need to optionally unwrap anything here. And I run my app again, and check my memory debugger for issues. Build, build, build. Check the memory debugger. Right? So same result, it also solves my memory issues. But again, right now the view controller owns this particular closure, so no problem. But if you're getting some network request, the closure is coming back from that network request, my view controller is no longer on screen, it will crash your app if you use unowned. So be very careful with when you use unowned. Yes, sir.
That was it. That was
Ask your question again and answer it.
No, I was going to ask, like, what circumstance would there be that self would be, like, nil?
Yeah, when the view controller goes out of scope. Yeah. Like you're waiting for some image to come back.
Yeah.
Closure gets dispatched. Your view controller is no longer on screen, right? Okay, cool. So we did a bunch of things. Let's go over everything we did here. I probably made some notes here. Please take some notes in that particular lab, okay? It's one of those things that'll come back. The next time you really need this is when you're interviewing, right? When they ask you to explain weak versus unowned, and you're like, oh my God, where do I start? I know I've been using it, but I don't know what it is. So the articles I shared, the Swiftly article, the ARC article from the Swift language guide, and this particular project will give us what we need. And I'll actually post the project up with all the issues not solved, so that when we come back for practice, we could solve those issues. Everybody with me? Okay? So we know we have memory issues there. We know how to solve them. Yes, go ahead, Tiffany.
Sorry. After the number memory leaks, how do you see what's connected? Like, how do you show that?
What's
Once
connected?
I don't have it, I can't see the things that were on previous.
Let me go back here. So you mean like when you're in the memory debugger, you don't know how to get out? Is that what your question?
No, like when I get there, it takes me to a different page, and it's like I have to press on.
So if you're in the memory debugger, right, to continue your application, you click on the play button.
Oh, this is that again. I'll look at something.
All right, cool. No worries. Okay, so we spoke about ARC. What does strong reference retain cycles cause, right? What does it cause? It causes the app to eventually crash. If you have a lot of memory leaks in your app, it will eventually crash the app, okay? It used to happen more before because our app itself had less memory. Our phones had less RAM, right? So the crashes used to happen more frequently before. Now we have a lot more RAM. Developers are getting a lot more careless. They're okay, whatever, because we have all that RAM in there, right? So no memory issues so far with like bad apps, right? But know that as a developer, don't take for granted that your app will crash if you have memory leaks there. It will also give the user a bad experience. I think I was using some app, and then the app was just sluggish. I had to restart my thing. I knew exactly as a developer what is going wrong. I had to restart my whole app or my whole phone to make the thing work, right? Cool. So be careful there. The next thing is, okay, so explain strong versus weak. The three reference types, we know that. So var name, right? Weak name, and unknown name. Know those? We saw an example of the class versus class memory leak there. We saw person having a stronghold on apartment, apartment having a stronghold on person. We just had to set one of those weak or unowned, and it would take care of it. Everybody with me? Okay? Next up, we saw the big one is closures. We use closures everywhere, and closures capture values. Anytime your closure is capturing self, right, or any value outside of the closure, be careful there. Break that memory cycle. Remember, structs and enums are not reference types, okay, and are not stored and passed by reference. Arc frees memory when a class no longer is needed, okay? When all strong references are nil, arc will free the memory. And again, arc is automatic reference counting. Before arc, we had to manage memory, everything ourselves. So if you look at like old Objective-C stuff, you see retain one, release. You see auto release. There's a lot of memory management we had to do there, okay? Trying to access a freed object will cause a crash. Arc won't let us free objects as long as we've seen that. The dinit, we know dinit is only on structs, correct? Dinit does not work on, dinit is only on classes. Dinit is only on classes, not structs, okay? Not structs, okay, please. We saw the examples here. At this point, we saw person was not released because person still had a reference to it. Reference 3 was still pointing to person, so person wasn't able to be released. When two objects have strong references to each other, meaning each keeps the other around, that creates a strong reference cycle. So that's the big one there. And it could be strong reference cycle or retain cycle. They both mean the same thing. Retain cycle, strong reference cycle. We said strong reference cycles are broken either using weak or unowned. A memory leak is caused by strong reference cycles. This particular one here caused the memory leak because both objects were holding on to each other. Couldn't let go. Jack let me go. Cool. Unowned here, we said with the customer object earlier in the Apple documentation. This is one of those you want to read during while searching for jobs. You have to read that article and know that article and how to explain it really smoothly to your interviewer. Arc is big. Capture lists we spoke about. We said what capture lists are. Use unowned if both objects refer to each other, right? And will always be deallocated at the same time. That's big. If the captured reference will never become nil, use unowned. But please use unowned cautiously. Be very careful there. It's like banging, right? Know exactly. It's like one of the things, it comes to experience. You're like, oh, why do we use fatal error sometimes? Or why we don't use fatal error sometimes? I use fatal error because I know I need that app to crash, right? But your customer doesn't want the app to crash if there's no connection on the internet, right? But as a developer, I want it to crash if the cell I'm getting back is not the correct cell. Same as banging. There's places where you could bang. I could bang on an image. That image better be in my assets folder, or else crash the app before I ship it. Cool. All right. This is it for today. Any questions? Yes, sir. Oh, sorry. Yes, ma'am. My eyes is blindly watching between. I thought I had peripheral vision, but not so well. Can I explain the closure thing one more time? Yes. Let's go back to it. But are you walking away though?
No.
Okay.
She's about to leave.
Yeah.
Like, can you explain it, please?
Yeah, I didn't get you said like the stuff outside of
Okay. The definition of a closure says a closure captures its values. So by that definition alone, it means that if I have a closure and it captures self, that means now it has a hold on self. That means now it has a reference. Basically, it's creating like var closure equal to self. You see what I'm saying? So basically, you could envision the closure as doing this, like var closure equal to self. What type of reference is that? It's a strong reference, right? right? So now that closure has a strong reference to self. And self itself has a strong reference to the closure, right? So they both have a strong reference to each other. What does that create? A cycle, right? Retain cycle, right? Retain cycle or strong reference cycle. And what does that ultimately lead to? The purple arrow is what? A memory leak, right? And what do memory leaks eventually lead to? Slow, crash, right? 1 star, delete app, right? All those things, right? That's where it goes, right? So if you have a lot of memory leaks in your application, they run slow, eventually it will crash. Eventually the system itself will crash the app because that app is using too many resources, right? We've seen Xcode itself crash many times. It only has memory leaks too, right? So our apps itself on our iOS device has memory issues, they'll crash. I use Zwift. Zwift is a heavy memory hog and also battery hog, right? That leads to, again, I'm just like a avid customer, so whatever, like it takes battery, I don't really care. But not all your customers will have that sort of loyalty to your app. If your app has a bad experience, they'll delete the app and give you bad reviews.
Okay, but what we had before the unknown self was just lab.
Oh yeah, so what we had before the unknown self was not breaking the reference at all.
Because it was strong.
Strong reference, right? Exactly. There's no like var whatever here. Yeah, exactly. It's implied. Very good, very good, very good. Everybody got Chelsea's, right? So she wasn't able to, she said, hey, go over it again, which is fine. Let's go over it again and understand what's happening. So when you have your closure and it captures self, stop and think of what you're doing. Either you do weak or you do unowned, right? Everybody? Cool? All right, so we will stop here. And please keep this ARC project very close to you because weak versus self, again, every weekend there's a new article on weak versus self. Like seriously, every week there's an article on this.
Someone just discovers weak versus self every week.
Yes, every week. There you go. Bam, all day. He's here all day. So those articles are there. Those are one of the topics you want to read again and read again and read again and just understand it.
Do other programming languages have ARC?
There's garbage collection in like Java, right? What's the Java developer here? I thought I was a Java developer. Garbage.
That sounds more straightforward.
Yeah, and C++ I think too has garbage collection. Yeah. We have Arc. At least Arc came. Before Arc, let me see if I could get anything like retain. 2013, that sounds right. That's an ARC. I got introduced later. Cocoa if love. Yeah, that probably sounds good. Yeah, I was trying to get like a code snippet for you guys. We've actually like doing it manually. Who knows? You might have to do it at Google. I don't know.
Because they still use. Wait, aren't they gonna start using Flutter for everything?
Flutter, yeah. All right, cool. Any other questions? We saw memory management today. We have all the articles we need, and we have the projects to check it out. And we will be breaking our cycles now in closures. Correct? Yes, Julia? Maybe. Okay. I'll stop here.